These boards use what's known as double-sided plated through holes. And the trick with plated through holes is it's very easy to damage them. So in removing these capacitors, you want to do it slowly. Here's the next capacitor we're removing. And what I'm going to do first of all is I'm going to put a little bit of solder on the individual lands that I'm going to remove. And then what we're going to do is we're going to very gradually rock this capacitor against whatever direction is here. You can try solder sucker, you can try solder wick, but with the plated through holes, it's just very difficult to get all the solder out. So we heat the negative connection and I move it ever so slightly in the other direction. Now we're going to heat the positive connection and again rock it back ever so gently. And really just don't try to do a lot at once, because what will happen is you'll rip out the hole. But it'll slowly start to creep its way free. Make sure the joint heats up to the point where the solder actually is melted whenever you do it. And just very gradually move it back and forth. And pretty soon you'll have the capacitor out. And before you try to put the next capacitor in, you really want to clean up that point connection that it goes into so that the hole is wide open. Best using a very high-grade solder wick. Some of the cheap shit that's sold just doesn't work. This is chem wick, and I've had very good luck with it. And you want to get it to the point where you're bleeding the solder through until you have a nice open hole. You can see through to the other side of the board, so the new capacitor will go right in there. And the other thing that I didn't really mention on the last video when I was talking about the pinball machine is with capacitors you have to watch polarity. There's a plus and a minus. So if we look at this board, we can see that there's a little positive next to this terminal on each of the places where the capacitor goes in. And it's very important that you put the positive and the positive and the negative, otherwise the sucker will actually blow up when you power it up. So yeah. What I did is I actually dated or put a little P-Touch label on the caps and put the date on it for the future reference. That way if someone goes in the machine, they know the caps have been changed. And also, since we're doing 6 of them, we won't mix up the old ones with the new ones. So before I put them in, I dated them. Also, there's 5 of these on this machine. On the last video I said there was 6. I don't know what I was counting, you know. Obviously I didn't listen to Sesame Street enough. But, you know, we're going to set the polarity correctly. And we're going to try to put these through the holes like that. And there's a little bit of lead that'll extend past. You don't really have to worry about cutting that lead off. In this particular case, these 2 locations, the 2 capacitors are paralleled, and it's a very high current application. So I'm actually going to take a little bit of a jumper wire and put it between here. There's a trace on the other side, but you never can be sure of the integrity of the trace when you've soldered on the plated through holes, or you've pulled things out of the plated through holes. They're very easy to damage. Here's a better view of the jumper I put in there. The leads on these things are a little bit better than 1/8 of an inch extending, and since the shield that's behind this board is about 1/2 of an inch back, we don't really have to worry about trimming the leads down to the board. You can if you want to. And with all 4 caps in, that's what it looks like. There's one on the other end of the board, which I'm about to change out now. One thing I should say is take your phone and take a picture of all your wiring connectors going onto the board before you pull the board out of the machine, because it can get a little daunting if you're not familiar with how those connectors go in. Also, if you're in a high static environment, you want to ground yourself and use a grounded iron, and even a wrist strap if it's really bad. Winter months tend to be really bad. There's not too much digital circuitry on this, and there's no CMOS, which is fragile to static, but I would do it anyhow. Also, this regulator transistor, in fact anything heavy like that, you want to take a peek at what the solder lands look like on that transistor. And it's not a bad idea to touch them up, Because the transistor, the case, the metal, and the solder, and the pads all expand and contract at different ratios, what can happen over the years is you get what's known as a ring crack, which is a tiny little crack around where the lead comes through the board. So you want to just heat that lead up and solder it in. Generally speaking, the regulators are good. There's a substitute available should you have a failed regulator. If you have a failed regulator, you won't so much get the kick out when you hit the flippers, but you'll probably get random shutdowns. When they go flaky, they just drop the 5-volt bus occasionally. The fact that we're seeing it modulated with power usage on the flippers tells me that there was a capacitor problem, but these have been known to go bad, although it's kind of rare. You should be good to go once you have all 5 of those caps changed. We have one more down there that we gotta change, and then we'll put it all back together and make sure it works.